Now that we have learned about the theory behind data analysis, that is, the importance of having a systematic process for data use in place, the types and purposes of assessment, and how different types of assessments function together to form a comprehensive assessment system, we are going to spend the remaining lessons focusing on the step in the process that guides action and change: data analysis and interpretation. To start the process of analyzing and interpreting data, we need to first ensure that we have both a shared vocabulary of data analysis concepts and terminology, as well as the ability to use data tools to query different reports based on the questions we are asking. We will begin by talking about student growth and continue with exploring how to look at Arkansas data using the QuickLooks website, along with the framework for data analysis. For the following lessons, you may find it useful to refer to Handout 4.1 for clarification and greater explanation of common data terminology. We're going to start by talking about student growth. Specifically, how do we measure a student's academic performance over time? This is actually an important question because much of a student's academic performance is based on what he or she has learned in prior years. If we can look at scale scores, proficiency, and growth, it might help us find students that seem to be doing fine academically, but which may actually be at risk for slipping in proficiency. If we have a measure for student growth, it will also give us another dimension by which to judge the strength of our academic programs. One simple measure for growth would be to look at the difference in scores between 2 years. For example, Noah scored a 702 on the 5th grade math benchmark in 2008 and a 775 on the 6th grade math test in 2009. His friend Ben scored a 425 on the 5th grade math test in 2008 and a 527 on the 6th grade math test in 2009. Since the difference for Ben between the 2 years is 102 and the difference for Noah is only 73, can we say that Ben grew more from one year to the next? The answer gets a little complicated when we consider that Noah's scores for both years were near the top. This means there is actually much less room for Noah to increase his score. Ben, on the other hand, is much nearer to the lower end of the scores. You can see this by looking at how far he would need to come up to match Noah's score. Ben has much more room to increase his score than Noah, so we can't really say that Ben grew more simply because the difference in scores between the 2 years is greater. If you've ever had to take a child to the pediatrician, you may be familiar with a different measure for growth. When I took Caleb to the pediatrician for his checkup, she told me Caleb had grown 3 inches. I didn't know what normal growth should be for someone of Caleb's age, but she told me he was in the 60th percentile for growth for infants his age. If we measure growth as a percentile, it allows us to understand growth as relative to a particular cohort. This would help us with the problem of determining growth for students who are at much different levels of performance, like Noah and Ben. If you look at a bell curve, you can see that it describes the distribution of percentiles. For example, if your score is in the middle of the bell curve, or the average, you are at the 50th percentile. If you are 1 standard deviation above the average, you are at the 84th percentile, and if you're 2 standard deviations above, you're at the 98th percentile. Going the other direction, if you're 1 standard deviation below the average, you're at the 16th percentile, and 2 standard deviations places you at the 2nd percentile. At the state level, the scale scores for each exam represent a bell curve. So if you were to take 2 tests, such as the grade 5 math test one year and the same student's grade 6 math scores the next year, you would have 2 bell curves that are crosswise to each other. The 2005 scores make one bell curve, and the 2006 scores are another bell curve transverse to the 2005 scores. If you were to select all the students that scored 600 in 2005, you would see a bell curve for their 2006 scores. Here's what that would look like. The 2006 scores for students that scored a 600 in 2005 represents a bell curve. If we draw a line where the first standard deviation is on this bell curve, we can see that represents a score of around 650 in 2006. So if you scored a 600 on the Grade 5 2005 exam and a 650 on the Grade 6 2006 exam, you would be at the first standard deviation above the average, or at the 84th percentile. Doing this for all scores and all students will allow us to assign a growth percentile to every student. For the purpose of your data analysis, we do not need to get into the complex statistics behind how the growth percentages are calculated and assigned using quantile regression, but if you are interested in learning more, you may want to research Damien Bettebeiner's work with the student growth percentile model. Now that we understand the basics behind the student growth percentile model, let's take another look at Noah and Ben. Plotting Noah and Ben's scores on the intersecting bell curves, the calculation showed Noah's student growth percentile was 54, and Ben's was 44. So now we can say that it was actually Noah who grew more between the two tests. More importantly, Noah was advanced in 2008, he was also advanced in 2009, and since his growth in 2009 was also above average, we know that Noah is on track to be advanced again in 2010. Unfortunately for Ben, he was below basic in 2008, below basic again in 2009, and his growth was also below average in 2009. We can't really expect Ben to have a dramatic turnaround in 2010 unless there is an equally dramatic intervention of some kind. You can also imagine a student that was proficient in 2009 but whose growth was below average. Such a student is at risk for not being proficient in 2010. It is not enough that we make our students proficient. We have to keep them proficient, as we also continue to help our non-proficient students reach proficiency. You can aggregate the student growth percentiles to the district, school, and teacher level. Again, one of the things represented by scale scores is the student's prior learning, with the student growth percentile specific to what happened between 2 years. This bubble chart shows scale and growth for middle schools in Little Rock for the 2009 Grade 8 Math exam. Scale scores are on the y-axis, and growth scores are on the x-axis. The size of the bubble represents the number of students tested at each school. Any school to the right of 50 for growth had above average growth, while any school to the left had below average growth. You can see that the school with the highest growth for this exam in Little Rock is around 60, and it was also one of the schools with the highest average scale scores. This is what we'd like to see for all of our schools: high scores and high growth. The standard deviation for growth among schools is 10, so the school with the highest growth in the Little Rock district is at the 84th percentile. Unfortunately, we can also see that there is one school in the Little Rock that had very low growth. This is also the same school with the lowest average scale scores. It is important to remember that the student growth percentile is not the Arkansas growth model. The Arkansas growth model is used for accountability, while the work on the student growth percentiles was done to help educators evaluate the performance of their programs and instruction. The student growth percentile is an objective measure of student growth and is used by 10 other states as their growth model under No Child Left Behind. While student growth percentiles are an important measure of student, school, and district performance, it is important to realize that this is just one part of what we should be looking at when we analyze our data. You will now complete a short activity to check your understanding of student growth percentiles. When you have finished, you will be ready to move on to Lesson 5. You have now completed Lesson 4. You are now ready to begin Lesson 5, preparing for data analysis using the Quick Look system.